Welcome to our deep dive into the AI revolution that's happening in science. We're going to be looking at a report from the Royal Society and the Alan Turing Institute, and really kind of digging into how artificial intelligence is changing how we think about and do scientific discovery. So get ready to go from like the really basic roots of data analysis all the way to some mind-blowing AI breakthroughs that are impacting like everything from astronomy to medicine.
Yeah, it's really exciting stuff. And it's not just about robots and labs, it's about understanding how AI is already changing how we do science, helping scientists analyze these massive data sets, extract hidden patterns and make these discoveries that I think were unimaginable maybe a few decades ago.
Right. And I think it's interesting to think back to like Kepler meticulously poring over Brahe's astronomical measurements, right? They figure out the laws of planetary motion, or even like the agricultural experiments at Rothamsted, where they had like decades of data. That led to some groundbreaking statistical methods. I mean, the quest to like analyze data and figure out what it means, extract insights, that's like woven into the fabric of science. But what we're seeing now with AI is like a whole new level of sophistication and power.
Yeah, and what's really exciting is that it's not replacing scientists. It's more like giving them a powerful new set of tools,
Yeah.
enabling us to tackle these complex problems that were previously intractable. Like, for example, think about the protein folding problem. That's something that's puzzled scientists for
Oh,
decades.
yeah. You mean figuring out the, like, intricate 3D shapes of proteins,
Yeah.
which is, like, crucial for understanding diseases
Yeah.
and developing new drugs.
Exactly. And, traditional methods were very slow and expensive. But DeepMind's AlphaFold, which is powered by a deep neural network, it can predict protein structures with like remarkable accuracy just from the DNA sequence.
That's wild.
It's a complete game changer, potentially revolutionizing drug discovery and personalized medicine.
That's incredible. So it sounds like AI is already making big waves in fields like medicine, but what makes, like, this moment in time so special for AI? Like, why is it so much more powerful now than, say, a few decades ago?
Yeah, that's a great question. I think there are three key ingredients that have kind of come together. One is we have access to these massive data sets thanks to the digital revolution. Two, we've developed these clever new algorithms like convolutional neural networks that excel at finding patterns in this complex data. And three, we have incredibly powerful computers now that can crunch these massive data sets and run these sophisticated algorithms.
Okay, that makes sense. But artificial intelligence, it's a pretty broad term these days, right? Could you unpack that a bit for us?
Yeah, of course. AI encompasses like a range of techniques and technologies that are all designed to essentially mimic human intelligence. It includes things like machine learning, where algorithms learn from data to improve their performance. Deep learning, where artificial neural networks are used to analyze complex data. And natural language processing, which enables computers to understand and process human language.
So instead of like explicitly programming computers to do specific tasks, we're now building systems that can learn and adapt on their own.
Yeah, that's a great way to put it. And it's this ability to learn and adapt that makes AI so powerful. Maybe I can give you a quick overview of some key AI techniques.
Yeah, bring it on. I'm ready to dive deeper into this AI toolbox.
Okay, let's start with convolutional neural networks, or CNNs for short. These are particularly good at analyzing images. You can kind of think of them as like a digital detective trained to spot subtle patterns and features that might escape the human eye.
So like how facial recognition software can identify people in photos.
Exactly. But CNNs are doing much more than that. They're being used to analyze medical images to detect diseases, to track deforestation patterns from satellite imagery, and even to help self-driving cars navigate the world.
It's amazing how this is impacting so many different fields. What other tools are in this toolbox?
Well, another fascinating technique is reinforcement learning, where an AI system learns by trial and error, much like we do. Imagine a computer playing a complex game like Go. It makes moves, observes the outcomes, and gradually learns which strategies lead to success.
So it's like learning to ride a bike. You try, you fall, you adjust, and eventually get the hang of it.
Precisely. But instead of bikes, these AI systems are tackling challenges like designing quantum experiments or optimizing energy grids.
Wow, that's some serious problem-solving power. What else is in store?
Well, there's transfer learning, where an AI system takes knowledge learned in one area and applies it to a new, unfamiliar domain. It's like learning to play the piano and then finding it easier to learn the guitar, because many of the skills transfer over.
Ah, so it's like building on existing knowledge instead of starting from scratch every time. That's efficient.
Very much so. And then we have generative adversarial networks, or GANs, where two AI systems are pitted against each other in a kind of creative duel.
A creative duel. That sounds intriguing.
Imagine one AI system trying to generate realistic images like a fake human face, while another AI system tries to detect the fake. And so this back and forth competition pushes both systems to improve, leading to these incredibly realistic outputs.
That's fascinating. It's like a digital art competition where AI systems are trying to outdo each other.
That's a great analogy. And GANs are being used to create everything from realistic images and videos to new musical compositions.
So these AI techniques from CNNs to JANs, they're like specialized tools in a scientist toolkit, each with its own strengths and applications.
Absolutely. And now that we've kind of explored some of these key tools, let's delve into how they're being used to drive real-world scientific discoveries.
Okay, so we've unpacked some of these core AI tools driving this revolution in science.
Mm.
Now let's get to the fun part. How is AI actually being applied to solve real-world problems and, make groundbreaking discoveries?
Yeah, so, we talked about AlphaFold and its success in predicting protein structures, which has, massive implications for medicine and drug development. But that's just one example. AI is making waves in, diverse fields, everything from astronomy and climate science to even things like social history and materials research.
Okay, I'm ready to be wowed. Give me some more examples of AI in action.
Okay, let's shift our focus to the vast expanse of space. AI is playing a really crucial role in astronomy, helping scientists analyze these massive data sets from telescopes and make sense of the cosmos.
So it's like having an AI assistant that can sift through mountains of data and free up astronomers to focus on the big questions.
Yeah, that's a great way to put it. So, for example, the Kepler Space Telescope, which was designed to hunt for exoplanets, generated an enormous amount of data. But this data wasn't always clean, you know? There were distortions caused by the spacecraft itself or variations in stellar activity.
So it's like trying to listen to a faint whisper in a noisy room.
Mm-hmm.
How does AI help filter out the noise?
Well, researchers have developed these sophisticated machine learning algorithms that can automatically identify and remove these instrumental artifacts, essentially cleaning up the data. And this has allowed astronomers to make more accurate measurements and even discover new exoplanets that might have been missed otherwise.
That's amazing. It's like giving astronomers a new set of eyes, allowing them to see further and clearer into the universe.
Precisely. And AI isn't limited to just cleaning data. It's also being used to discover entirely new astronomical phenomena. For instance, AI has been instrumental in uncovering new pulsars, those rapidly spinning neutron stars that emit beams of radiation.
Okay, that sounds incredibly complex. How,
Yeah.
how does AI help with something like that?
Well, pulsars can be difficult to detect because their signals are often very faint and easily obscured by noise. But AI algorithms trained on massive data sets of astronomical observations are able to pick out the telltale signs of pulsars, even in the most crowded and noisy data sets.
So it's like having an AI detective that can spot clues that humans might miss.
Exactly. And this has led to the discovery of many new pulsars, providing valuable insights into the evolution of stars and the nature of gravity.
It seems like AI is transforming astronomy, giving us a deeper and more detailed understanding of the universe. But what about closer to home? How is AI being used to tackle pressing challenges like climate change?
Yeah, that's a great question. AI is playing a crucial role in climate science, helping us understand and predict the impacts of a changing climate. One of the challenges in climate modeling is bridging the gap between these large-scale global climate models and the localized impacts that people experience on the ground.
So it's like taking those big global predictions about rising temperatures and sea levels and figuring out how they will affect specific regions and communities.
Precisely. And AI is proving to be invaluable for this task. For instance, researchers are using AI to predict how climate variability will impact crop yields in different regions, helping farmers adapt to a changing climate.
That's incredibly important, especially in regions that rely heavily on agriculture. It's like AI is providing a more detailed roadmap for navigating the challenges of climate change.
Exactly. And this is just one example. AI is being used to track deforestation patterns,
Right.
predict extreme weather events, and optimize renewable energy systems. It's becoming an essential tool for understanding and mitigating the impacts of climate change.
It's inspiring to see how AI is being used to tackle such a complex and pressing global challenge. But I'm curious, are there any areas where AI is making unexpected contributions? Fields that might not immediately come to mind when we think about artificial intelligence.
Absolutely. AI is quietly making its mark in a wide range of fields, including things like social history.
Hmm.
Researchers are using AI to analyze these vast archives of digitized historical documents,
Yeah.
like newspapers, diaries, and letters.
So it's like having an AI-powered research assistant that can sift through millions of pages of text looking for patterns and insights that would take humans years to uncover.
Exactly. For example, researchers have used AI to analyze newspaper articles from the Industrial Revolution, gaining new insights into how people lived, worked, and interacted during this pivotal period of history.
That's fascinating. It's like AI is helping us rewrite history books with a more detailed and nuanced understanding of the past. What other surprises does AI have in store?
Well, AI is also making waves in the field of materials science. Researchers are using AI to discover new materials with specific properties, like strength conductivity or heat resistance.
So it's like having an AI-powered chef that can experiment with different ingredients
Yeah.
to create a dish with the perfect flavor profile. But instead of food, we're talking about materials with specific properties.
That's a great analogy. And this approach is accelerating the discovery of new materials for everything, from batteries and solar panels to lightweight aircraft components. And next generation electronics.
It seems like AI is impacting virtually every scientific discipline, from the cosmos to the microscopic world of materials.
You're absolutely right. And we've only just scratched the surface of what AI can do. There are many more exciting developments on the horizon.
Okay, I'm officially hooked. This is all incredibly exciting. But with all this talk of AI's capabilities, it's important to remember that there are also challenges and questions we need to consider as AI becomes more deeply integrated into scientific research.
Yeah, you raise a crucial point. While the potential of AI in science is undeniable, there are also important considerations about, things like data management, the transparency of AI systems, and the evolving role of human scientists in an AI-driven world.
Yeah, that's what I was thinking. Let's delve into some of those questions
Yeah.
and explore the potential challenges and opportunities that lie ahead. As AI continues to reshape the scientific landscape, we've seen how AI is like revolutionizing scientific discovery, predicting protein structures and uncovering hidden pulsars. But as AI becomes more powerful, we need to kind of think critically about its integration into scientific research. So what are some of the key challenges that we need to be mindful of as we move forward?
Well, one challenge centers around data management. We're generating more data than ever before, but how do we decide what to keep and what to discard? What does open data even mean when data sets are so vast that no single person can grasp them, in their entirety?
Yeah, it's like building this massive library, but lacking a good system for like cataloging the books or knowing what's on the shelves. It's a daunting thought.
Indeed. And then there's a question of AI methods and capabilities. How can we ensure that AI results are not just statistically significant, but also scientifically meaningful and understandable? We don't want AI to just spit out numbers without any real insight into what those numbers mean.
But a scientific breakthrough isn't a breakthrough if we can't explain the reasoning behind it. It's like finding a treasure chest, but not having the key. We need to understand how AI arrives at its conclusions.
Exactly. In science, it's not enough to know something is true. We need to understand why it's true. So if we're relying on AI to make discoveries, we need to be able to trace its logic, see the connections, and ensure that the results are scientifically valid, not just statistically significant.
So how do we address that? Is it even possible to make these complex AI systems more transparent?
It's a challenge, but researchers are developing new algorithms that are designed for interpretability. They're also creating tools that help us visualize and understand the decision-making processes of AI models, kind of like building a window into the black box.
Okay, so we can see the gears turning, so to speak. This leads to another big question. How will AI change the role of scientists? I mean, are they going to become obsolete?
That's a question that sparks a lot of debate. Some fear that AI will replace scientists altogether. But I believe that AI is ultimately a tool, and its impact depends on how we use it. AI can analyze data, identify patterns, and even generate hypotheses. But it's still humans who ask the questions, design the experiments, and really make sense of the results within the broader context of scientific
So
knowledge.
it's not AI versus humans. It's more like AI and humans working together.
Precisely. I see AI as, an indispensable partner for scientists, augmenting our abilities and helping us push the boundaries of discovery further and faster. It's about collaboration, not competition.
That's a reassuring thought. So as we wrap up this deep dive, what's like the one key takeaway you want our listener to ponder?
Well, I think AI is revolutionizing scientific research in profound ways, opening up these new avenues for discovery and understanding. But it's crucial to remember that AI is a tool. And like any tool, its impact depends on the humans who wield it. As we embrace the potential of AI, we must do so thoughtfully, ethically, and with a focus on collaboration between humans and machines.
This has been such a fascinating exploration of AI's impact on science. We've journeyed from, these fundamental principles of AI to its awe-inspiring applications in these diverse fields. It's clear that we're on the cusp of like a new era of scientific discovery, one where AI will play an increasingly important role. To our listener, we hope this deep dive has sparked your curiosity and provided some valuable insights into this transformative power of AI. We'll be back soon with another fascinating topic. Until then, keep those minds curious to chop